The digitalization of an industrial company involves integrating digital solutions at all levels of its processes to optimize productivity, performance, and innovation. Our digital solution supports this transformation by facilitating the integration of advanced technologies to make the company more agile, responsive, and competitive in a constantly evolving industrial environment. The preventive services of the MAD, located in the cockpit room, collaborate to form an efficient machine that allows for real-time tracking and management of a company's resources. It is based on two basic functions: tracking and management. Workshop information is transmitted to the station where it is processed and displayed as indicators through tracking and control services. The station can also transmit management orders to facilitate interventions during production. This shared data is transferred either to local databases or to cloud data centers. Information from different services located in manufacturing workshops can be entered in two ways: either by operators using user-friendly services specially designed for them, or automatically through connected machines. All this data from the manufacturing workshops constitutes big data, which offers us a virtual representation of the factory in production mode and allows us to monitor all production processes. The MES services are managed by two systems: the SAD, Data Acquisition System, which collects and transmits information from the manufacturing workshops to the cockpit, and the MAD, Data Analysis Engine, which performs the calculation and analysis of data from the manufacturing workshops, transforming them into relevant performance indicators. The SAD is composed of two essential services. The first, Ouvraison, is a service integrated into the data acquisition system, accessible to production and maintenance operators. It allows for the recording of all activities at a workstation, thus playing a key role in real-time monitoring and the collection of strategic information. The second service, ORI, is specially designed to optimize the transport of material flows within the workshops. It ensures rigorous tracking of material movements from one workstation to another, relying on advanced traceability tools. Thanks to real-time control, it allows monitoring of routes taken, loads transported, and quickly identifies any necessary interventions, thus ensuring smooth and efficient management of production flows. The MAD system offers a wide range of services dedicated to tracking and control, enabling in-depth monitoring and optimized management of production performance. We will now explore the MAD services, data analysis engines. Dashboard for workstation tracking. We will explore the fundamental features of the workstation tracking service of the cockpit station, which offers complete visibility on production, operator downtimes, material and machine management. This service allows for real-time or delayed management, thanks to detailed and colorful graphs for each step of the production process, optimizing performance and interruption management. Dashboard for tracking work in progress products. The cockpit station offers real-time tracking of work in progress. We will examine in detail the essential features of this service to provide information on the production status of products by reference, including tracking the quantity produced and their location along the production line. Dashboard for tracking operator performance. We are now exploring the key service of the cockpit station. Operator tracking ensures precise supervision of the production or service process, including management of individual performance, schedules, tasks, and breaks, aiming to optimize productivity and ensure compliance with quality and safety standards. Dashboard for tracking production stoppages. We will examine how to monitor the production stoppage tracking service of the cockpit station, which allows immediate monitoring of production interruptions and analysis to optimize downtime management, thus improving overall workshop efficiency. Monitoring of the manufacturing workshop. This service offers an interactive real-time map of the manufacturing workshop, accurately showing the location of workstations and their status, whether in production, stopped, or under service. It also integrates operator management to track their assignments and status. With automatic alerts and collected data, it optimizes supervision, reduces inefficiencies, and improves resource management and overall productivity of the workshop. Dashboard for monitoring OEE calculation. We will examine in detail how to calculate the overall equipment effectiveness, OEE, essential for evaluating the efficiency of a workstation in production or service, by identifying losses such as downtime, breakdowns, and quality issues. Dashboard for quality monitoring and management. The quality management service provides complete and in-depth visibility on non-compliant parts, based on data collected from the processing service. Thanks to the entries made by operators, precise and real-time traceability of anomalies is ensured. This service stands out for its ability to codify anomalies with great precision, allowing them to be categorized according to different criteria, making it a key tool for quality managers. Management of workstation rates. The machine rates define the production speed per machine for a given product, which is essential for productivity and profitability. We will now explore how the processing service allows monitoring of this rate, which is crucial for optimizing efficiency in industrial operations. Administration of workstation schedules. The management of schedules is designed to plan and accurately allocate the hours of each workstation throughout the year. This system allows defining operating periods, planned downtimes, as well as specific time slots for each workstation. By organizing production time in this way, it becomes possible to rigorously calculate key performance indicators such as OEE, overall equipment effectiveness, OPE, overall performance efficiency, and OEE, overall economic efficiency of each workstation. Management of series change orders. The tool change order is a service that tracks tools from their release from the store to the workstation, and vice versa. Each tool comes with a tracking label that records its movements step by step. This detailed tracking allows for control of the location and lifespan of each tool, facilitating stock management, replacement planning, and preventive maintenance, while ensuring uninterrupted production related to tool failures. Machine tool management. A tool is composed of several components, each dedicated to a specific machine and product. It is essential to create a bill of materials for each tool to define the components necessary for its operation. A control system overseeing these components allows for tracking their status, ensuring their correct use, and managing their maintenance, thus guaranteeing optimal production without interruptions due to failures. Dashboard for MN1 monitoring. Level 1 maintenance intervention is carried out in the machining department where the operator follows the assigned tasks step by step. The results of these interventions are displayed in this department in the form of a dashboard that allows for tracking and controlling all actions performed. Follow-up of rework orders. The rework order is intended for parts that do not meet quality standards. A service generates a rework order accompanied by a tracking label for each part, allowing for detailed tracking of each step in the rework process. This ensures that corrections are made correctly, guarantees the compliance of parts, and optimizes the process by identifying the causes of non-conformities and improving production. Load plan management. The load plan is a real-time management service that monitors production and allows for quick action in response to anomalies. It immediately detects disruptions, such as breakdowns or delays, and enables rapid intervention to correct these issues. Furthermore, it optimizes resource allocation and adjusts priorities to ensure smooth production, thereby maximizing efficiency and reducing costs. Timekeeping system management. The time clock is an attendance management service that monitors operators' entry and exit, providing real-time visibility on their absences or delays. It automatically records work hours, generates alerts in case of absence, and allows for efficient human resource management. This system optimizes production planning, facilitates tracking of hours worked, and ensures precise absence management for better organization and productivity. As an example, we will detail the workstation tracking service and demonstrate some of the basic features. This service offers complete visibility on production and stoppages of each workstation. It also ensures effective supervision of the three fundamental elements of production: the operators, the materials, and especially the machines. Additionally, this service offers a dual possibility of tracking workstations in real time or delayed. Like the previous service, which tracked work in progress, a panel on the right displays the schedule for a month's session. The session starts at 6 in the morning and ends at 2 in the afternoon. It is currently 1:31 p.m. A window on the left shows the list of workstations currently in production. We select a workstation as an example, workstation P043. The green rectangles illustrate the graphs representing the production flow of workstation P043. These graphs provide a clear and precise visualization of each step in the production process. The green rectangle represents production, while the gap between the two green rectangles symbolizes a production stop. And the stop itself can take several colors, and each color indicates the type of stop. This zoomed-in symbol, characterized by a vertical gray line, represents a momentary stop that occurs when a batch is completed. A black rectangle informs us that the operator has left their station. An apparent gap indicates that there is no more material for the station. A red rectangle is used as a signal to indicate that the machine has broken down. We now return to the gray line symbol that indicates the completion of a batch. As you can see on this chart, the gray line marks the completion of a batch, allowing us to count the number of batches completed up to the current time, which is 1:31 p.m. At this point, Station P043 has successfully completed 12 batches since 6 a.m. this morning. Here are the production graphs for all the stations. As mentioned earlier, this service also relies on visual management. Currently, our main concern is focused on the production stoppage, hence any stop will be signaled by a red rectangle. As you can see, we will highlight all the stops. This approach aims to make them more visible and significant. In the window on the right, we find several features that enhance this interface from the perspective of monitoring and controlling workstations. However, for our current presentation, we will limit ourselves only to the service that allows us to view production stops in detail. Just press this button to trigger the in-depth monitoring of stops.